In this video, I'm going to be showing you how you can make this pattern, this hexagon pattern, procedurally. So we make the logic that actually generates this pattern. This is done in blueprints. And you'll be able to have these types of controls that kind of show off, that allow you to make kind of the basics for whatever game that you want to make. This is a pretty popular pattern for all sorts of games, turn-based games, and a lot of logic kind of revolves around this hexagonal pattern. So we're going to go ahead and we're going to understand kind of the logic behind this, like how do we do tiling like this? What is important to make sure when you're designing tiles like these for your games? And then in the end, you should be able to build your own and I hope you really enjoy it. So now that we can begin, let's jump into Blender and let's build our first tile. So let's make a hexagon tile or hex tile. So I've opened up Blender, and the reason why I'm making it, even though it's a pretty simple shape, is I want to make sure that all of the sizes and all of the numbers are accurate, because it's gonna matter a lot when we do the tiling that everything is accurate. So this is just the default Blender scene. I'm gonna get rid of the default cube here. I'm gonna go and I'm adding a cylinder. So here at the bottom left, I have all of the properties here. The vertices for our hexagon is going to have 6 vertices, and the radius of what we're doing, we're going to keep that at 1. But this is probably the most important property that we need to make sure that we keep track of. It's the radius, because that's going to be the key number that we use in tiling. I'm going to make the depth, I'm going to make it a little bit smaller. So the depth is going to be 0.2. And then I'm going to move it on the y-axis, because, yeah, it's the y-axis. I'm going to move it up by 0.1. So, no, it's not the y-axis. We're not in Unreal. So I'm going to move it up on the z-axis by 0.1. And what we're going to end up with is a hexagon. And we have it kind of sitting nicely here on the ground plane, which is just nicer. And what you see when I'm looking at it is that the hexagon is filling out the space on the grid here on the sides, here on the y-axis, but it's not doing it on the x-axis. And we'll talk a little bit about this later. So the last thing that I'm going to do is, just to make it a little bit nicer, I'm going to select all of these edges here at the top. And I'm going to add a little bit of a bevel, something like this, and this is just to make it look a little bit nicer. So now I've created my hexagon tile. So the next thing is going to be, we're just going to export this out and import this into Unreal. But before we do that, I want to jump in and talk a little bit about the hexagon shape and how we're going to actually tile it over. Create a grid of the hexagons. So let's take a look at the hexagon. This is a regular hexagon, which means that it has all of the sides are the same length, and it means that it has 6 sides. Some of the properties or the anatomy of a hexagon is it's pretty interesting. We have a radius, like we looked at in the when we created the hexagon in Blender. So the radius is actually sometimes called size. And this is the distance from the center and to this corner here, the long corner here. And because because this is a regular hexagon, we know that the length of the side here is the same as the radius. So that gives us the information about how long each side is. And then another property, which is a little bit more interesting, which is the height. And this is the distance here on this area here, from the flat parts all the way down here. And if we take a look at the hexagon that we created earlier and give these some numbers, the size or the radius is 1. The width, that means that the width is 2, because we just take the size or the radius and multiply it by 2. The height is 1.732, or the formula for calculating this is we take the square root of 3 and we multiply it by the size or the radius. And I'm not quite sure why this is the case, so if anyone knows and cares to explain, I would love to hear it in the comments. So this gives us the height of the whole the whole hexagon. So you can see that the width of it is 2, but the height is a little bit shorter. And then the last property that's sometimes talked about is the perimeter. And the perimeter, because we know this is a regular hexagon, this is just the number of sides times the size. So this gives us 6. But what we wanted to do is we wanted to tile this. So with this information, we can create a tiling algorithm, or we can create a tiling program. So the first thing that we do is we shift the newly created tile. We start with a tile at the original position, or some known position. And to do the tiling, we shift on the x-axis, or to the side. We shift it by 75% of the width. So we don't want to shift it all the way, because then this corner here would be here, and that's not going to work for us. But then we also shift it up by, we take the height, we shift it up by half of the height. So we calculate the height, which is the square root of 3 times the size, and we divide it by 2, because we just want to shift it up by half of it. And then we just continue. We shift it again by 1.5, or 75% of the width, which gives us 3, and then we continue. So we can continue doing a tile kind of strip like this by just following this this algorithm. But our goal pattern is this, and we've pretty much created what we need to do that. So let's jump into Unreal and take a look at how we implement this. So now that we're in Unreal, I imported my hexagon here into the engine, and I've given it a material. So you can see here on the grid, if I go, I'm in the static mesh editor right now. So if I go and take a look at the top view, it doesn't actually show me the wireframe, but or the grid. So let's go back to perspective view. Okay, so we can see it here. So again, just like in Blender, we have all of the sizes correct. So the long side here is filling out the grid, and the short side is not. So basically here, I have the hexagon in here. So what we're going to be building is going to have this behavior here. So I've already created the actor here, but we're going to recreate it. But I just wanted to show you how it's going to work. So we're making logic that's going to allow us to create this kind of hexagonal strip before we actually do the grid itself. So as you can see, I'm just modifying a property here called rows, and that's going from, probably shouldn't be rows, but there's a property here that I'm modifying. So for any number here that I'm modifying, it's going to give us like one more piece or one more row once we actually go up and do the full grid. So this is what we're going to be building. So let's jump in and create a new actor. So I'm going to make a blueprint class and make an actor out of it, and I'm going to call it BP grid logic new, because this is a new one. So jumping into the actor, what we're going to do is we're going to do a little bit of setup. We're adding a static mesh instance, an instance static mesh here. So this is going to allow us to kind of stamp static meshes based on the locations that we give it. So I'm going to find our hexagon tile here, and you'll notice that nothing happened here in the viewport, and this is because we need to add an instance to it. Right now this is just an instance static mesh with no instances, so we need to do that. So when I'm working on something like this, I like to work in the construction script, especially for stuff that's kind of procedural or generated and stuff like that, because that any time that I compile, I don't need to press play or simulate or anything like that. This just happens automatically when the object is kind of refreshed. So I'm getting a reference here to the instance static mesh, and I'm going to do add instance. So this is going to give me, and it's going to add an instance. It wants an instance transform, so I'm just going to make an empty transform here. And now that I compile, you'll see that I have my mesh, and it's in the right size. And if I drag this here into my scene, you'll see that we have one of them. So the next step here is we're gonna create a loop, and we're gonna start making it tile. I'm gonna create a for loop. So this is gonna run. So the for loop is gonna run from an index, we can start at 0, for example, to an index. We can start, and this is just going to control how many tiles we want to show up. So if we say that we want 4, this is actually going to give us 5. So I'm going to start the first index at 1. Now that I've done this, this is going to create 4 instances. But what's going to happen is they're all going to be placed in the same location because I'm adding them all at the same location. So now let's start implementing some of the details in our algorithm or in our logic. I'm going to make a float here, and this is going to be radius. So the radius is 100. So even though we set the radius to 1 in Blender, once we exported this in, the coordinate system in Unreal makes it so that the size is 100. So I'm going into the top view. So you can just middle mouse drag and you can see that the radius here is 100. So our radius now is 100. So just like we did in the example before, we're going to multiply this by 2 to get the width. So make this big again. So we're going to multiply this by 2 to make this big. And then we're going to multiply that by 75%. So we don't want this to go all the way. We just want this to go 75% of the way. And we are going to put this into the y-axis. Because on the y-axis, if we take a look at the coordinate system here, we want to be tiling this from the long sides. So now, So now what's going to happen is it's probably just going to shift a little bit. Yep, here we go. But it's not actually tiling. And the reason for that is that we then need to take this number and we need to multiply this number with the index. So that means that anytime this runs, we shift it by, so on index 1, it's going to be moved by, it's going to be multiplied by 1, and then 2, and then 3, and so forth. So we plug this in here. And what we're going to see now once I compile is we have the grid correctly working, even though this doesn't really look correct. So we can go ahead now and we can just right click here on the last index and we can do promote to variable. And I'm going to call this number on Y. So it's not on the screen right now, so it's here. I'm going to add the click on the I button here, which makes this instance editable. So this allows me to go in here and do what I showed earlier. I can go in and I can just slide this to make this kind of make this go up and down. So the problem here is we're not doing the shift up, so we're actually just moving it to the side. So this piece here, every other piece is supposed to be it should shift up. So let's go ahead and implement that logic. So now we're going to do something pretty cool. So first we need to figure out what is every other tile. So the way that I like to do that is I'm going to use a modulo operator, and I'm going to say if the modulo 2, so I would also love to hear a good explanation on why this works. I read this online, so I can't explain why this works the way it does. But I know that if I check that a modulo 2 of an integer number, if it equals 1, then this is a round number. So if I change it like this and I say only do the logic when the number is round. If I compile this, you can see now it's skipping up 1. So now we have a space between them. So that's not really what we want to do. What we want to do is we want to say that on every other one of them, we want to shift them on the x-axis. So I'm going to make a new note here, and I'm going to actually make a new vector, make vector like so, and I'm going to recombine these here. So I can use because this is a Boolean value, I can use something called select. I'm going to do a select vector. So the select vector is going to take the number that the Boolean value, is this even or is this false? And it's going to alternate between entry A and entry B based on that. So I'm going to use the result of this and I'm going to plug it here into the location. So if the number is even, we're going to use our original value, which was the y-axis was here and the x-axis is 0. So we should be still seeing the, didn't plug it into, yeah, so we don't have the execution node. So this goes in here. So we're getting every other one here. So now we need to make the transform, or make the vector that's going to be the same one, or the same one, but it's going to be shifted on the x-axis. So the y value stays the same, but now we implement the second part of our algorithm, or second part of our logic, and we take the radius that we had here. I'm just going to duplicate it. We take the radius, we multiply the radius. I'm going to do multiply. We multiply it by the square root of 3. So here we go. And we take the square root of 3 and we divide it by, and that's going to give us the height, the full height of it. We're going to divide that by 2 because we only want half of it. So here now is getting a little bit dirty for us. Now we should be able to plug this into the x value, and now it looks like it's starting to behave the way that we want it. So now that I move it up and down, you can see that we've basically recreated this single grid line of tiles. So now we pretty much have everything that we need. We have the math behind this. So now all we have to do is we need to adjust the logic a little bit to make it so that we shift it up so that it actually forms a grid and not just a strip. So let's take a look at how we do that. All right, so let's make a tile on the other axis as well and finish our grid. So I'm going to make it just as straightforward as possible. The code is not going to be very clean, so you can easily clean it up, but I'm just going to try to make sure that you follow the train of thought. So we have the height here. If you remember from before, we made the height by taking the radius and we multiplied it by the square root of 3, and then we divided it by 2. So what we need to happen now is we need to shift the whole thing up by, or on the x-axis in our scenario, we need to shift everything by the height. So I'm going to take the height here and I'm going to copy it and I'm going to paste it over here. So this is where it would be pretty easy just to say this as a variable, but I'm going to say height here. And now that I have a copy of my height, I'm going to add another for loop. And I'm going to say that for before we do anything, we're gonna have like this. This is what we call nested loops. So these nested loops, we're first gonna do one loop here, and while this one does one, this one is gonna run all of their all of their loops. So this loop is going to be doing the x-axis, while this one is going to be doing the y-axis. So I'm hard coding the numbers here to start with. So all we have to do now is, instead of saying where we were doing the coordinates here, we had the x value just hard coded at either 0, or we had it, that's not supposed to be here, we had it hard coded on 0, or we had it shifted by half of the height. So all we have to do now is, in our external loop, or the loop that is supposed to move us up on the x-axis, we take the height, the full height, and we multiply the full height with the index. So this is going to be 1 in the beginning, and then the next time that we run it, this is going to be 2. So if we plug this into the height, into the x value here and compile, we can see now that every other tile is being placed. Oops, let's try to slow down the camera a little bit. Yeah, so we can see that every other tile is now being placed in the correct spot, and that's because we've dealt with the case on the even numbers here. So and now we just repeat the same thing. We have the logic here. This is the half step push up. So let's copy this again, and again this could be made much more beautiful. So we're going to take the height. We're going to multiply the height by the index on the x-axis, the outer the outer loop, and we're gonna add that to our offset. So or basically we're gonna take the full offset and then we're gonna add the kind of the half offset, and we plug this in here. So now that we compile, now we pretty much have our grid. So our hexagon grid. So all we have to do now is we right click on the outer loop, do promote to variable, and we do number on y, number on x. Compile this, make it instance editable again, and now that we go in here and select it again, you can see that we can, if we do number on x, you can see that it goes on the grows on the x-axis, and if you do number on y, you can see that it grows on the y-axis. So this is pretty much kind of the basics of it. So now you should be able to make a grid that is as big as you want. It's pretty efficient when it comes to rendering because this is an instant mesh. So yeah, so that's pretty much what I wanted to show you on of the basics of this. I want to make a couple of more tutorials related to this and actually add things like how do you click on it, how do you highlight them, how do you animate them in, and even go as far as making them store state so that you can have them remember, you can make a save game and all of that stuff. But it's good to start with the basics. So if you have any feedback or any comments about what you want to see next, if you have any explanations about some of the math stuff that I'm not clear about, then definitely leave a comment. And hopefully I can follow this up with more videos that are based on these kind of hexagon pattern, because this is pretty cool and you can make some really interesting things with it. So until next time, thank you.